Good morning, students.
Good morning, sir.
Is
Morning,
screen
sir.
okay?
Good morning, sir.
Screen is okay?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, last class, did I give Cauchy mean value theorem problems assignment?
Yes, sir.
Yes, sir.
Okay, take some more problems. Assignment. First one, if in the Cauchy, f of x equal to square root of x, g of x equal to 1 by square root of x. Just 1 minute. G of x equal to 1 by root x. Then using Cauchy mean value theorem, show that there exists C belongs to open A comma B, which is geometric mean between A and B. Same second one, f of x equal to 1 by x square, g of x equal to 1 by x. Then using Cauchy mean value theorem, show that there exists C belongs to open AB. Which is harmonic mean between A and B. Okay, these two are the problems based on Cauchy mean value theorem. Next one is Taylor's theorem. Which is also called as generalized mean value theorem. This is generalized mean value theorem. If in the question only using mean value theorem means apply Lagrange's mean value theorem. When generalized mean value theorem is given, then apply Taylor's theorem. And statement is, if a function f is such that, or f of x, such that, first condition, the n minus 1th derivatives, that is nothing but fn minus 1x is continuous in the interval closed a comma a plus h. Closed a comma a plus h is nothing but parametric form. Okay, so we are defining Taylor's theorem in parametric form. And second condition, the nth derivative fn of x exists in the open interval a plus h. And third point, small p is a given positive integer. Then three conditions. What is the first? Okay, afterwards I will explain. Then there exists at least one number theta. Or one value theta. Theta belongs to what? In parametric form, that is belongs to 0, 1, such that now the Taylor's theorem, f of a plus h equal to f of a plus h into f dash a plus h square by factorial to f double dash a and so on, and plus h to the power of n minus 1 by n minus 1 factorial n minus 1th derivative a plus, and last remainder term is h to the power of n 1 minus theta whole power n minus p by n minus 1 factorial into p f nth derivative a plus theta h, f nth derivative a plus theta h. Take this as equation 1. This is Taylor's theorem. Taylor's theorem explanation. See, what is that? The function f of x is how it is defined. First thing, n minus 1th derivative is continuous in closed interval a plus h. And you know that, say here, generally, f dash x exists means what? F dash x exists means what? F of x is continuous function. Is it correct? Right? Is it continuous function? F dash a derivable function means the function must be continuous. There is a theorem. If f of x is continuous, then only it is derivable. And another one is what? Every differentiable function is continuous. So f dash x exists means what? F of x continuous. F double dash x exists means what? F dash is continuous and f of x also continuous. Similarly, f triple dash exists means what? Double derivative, first derivative and the function are continuous. So n minus 1th derivative is continuous means what? What this gives, n minus 1th derivative continuous means the function, first derivative, second derivative and all its previous derivatives. That means n minus 2 are continuous. N minus 2 are continuous. That means this first only one condition, n minus 1th derivative condition, continuous means what? The function and all its n minus 2th derivatives are continuous. And obviously it is given n minus 1th derivative is also continuous. First point is over. About continuity. And why this continuity is required? Let us see. Next, second condition, the nth derivative fnx exists. Nth derivative fnx exists means what? All its previous derivatives exist. All its previous derivatives exist as well as continuous. And there is a positive integer p. Then there exists a point c belongs to theta belongs to 0, 1 such that what is this? F of x is the function. Now in place of x we are considering a plus h. F of a is the point. F of a is the value of the function at a point a, and a plus h means what? Some neighboring point of a. F of a plus h. So when f of a plus h expansion, how to remember this? First write f of a. First write f of a plus this h into first derivative. Next plus h square by factorial 2 second derivative. And this is what? Actually there is no derivative here. There is no derivative here. 0 only. 0 to n minus 1 means what? 0 to n minus 1 means what? Nth, up to here n terms are there. Up to here this is nth term. This term is nth term. And this term is what? N plus 1th term. N plus 1th term. And how to remember? First write f of a. Next plus h into f dash a plus h square by factorial 2 f double dash a, and obviously n minus 1th derivative term, that is in nth term. N minus 1th derivative term is h to the power of n minus 1 by n minus 1 factorial nth derivative of f at a. And this last term, this is called remainder term. This n plus 1th term is called remainder term. And what is the remainder term? H to the power of n into 1 minus theta whole power n minus p by n minus 1 factorial into p, nth derivative at a plus theta h. Do you remember in Lagrange's mean value theorem parametric form, what we have to write? F dash of a plus theta h equal to f of a plus h minus f of a by h we have written. Now see this one. This f of a plus h becomes what? From this expression, f of a plus h becomes what? F of a plus this h into f dash of a plus theta h. So this is Lagrange's mean value theorem is also Taylor's theorem, but up to second term, but up to here. And since it is a plus theta h means this last term, that means in place of a here, you will get a plus theta h. That is the remainder term. Okay. So special case of Taylor's theorem is nothing but, if I consider only two terms, that is nothing but Lagrange's mean value theorem. And no need of derivation this. You have to remember this statement. Statement is very important. And this remainder term, what is this remainder term is called Sklomich and the Roque form of remainder. Roque form of remainder. This remainder term. Sklomich and a Roque form of remainder. And this I am writing here. This Rn remainder term, this h to the power of n into 1 minus theta whole power n minus p by n minus 1 factorial into p f nth derivative a plus theta h is known as Taylor's remainder. Is known as Taylor's remainder. Taylor's remainder, and also named as Sklomich and the Roque form of remainder. Sklomich and Roque form of remainder. Take this as expression 2. Take this as expression 2. Next one. Here cases. Coming to first case 1. Case 1. If p equal to 1, p is what? Positive integer. Let me take p equal to 1. Then what is Rn becomes Rn equal to h to the power of n 1 minus theta whole power n minus 1 by n minus 1 factorial. P value 1 multiplied by nth derivative at a plus theta h is called Cauchy form of remainder. Is called Cauchy form of remainder. When p equal to 1, this is Cauchy form of remainder. Okay. Therefore, Taylor's theorem. Taylor's theorem with Cauchy form of remainder. Cauchy form of remainder is now f of a plus h equal to f of a plus h into f dash a plus h square by factorial to f double dash a and so on plus h to the power of n minus 1 by n minus 1 factorial f n minus 1 a, and lastly this up to here n terms are over. Now n plus 1th term, that is the remainder h to the power of n 1 minus theta whole power n minus 1 by n minus 1 factorial f n a plus theta h. This is Taylor's theorem with Lagrange's form of remainder. And case 2. Case 2. If p equal to n, then what is Rn becomes? Rn becomes, see, p equal to n means this one now. So this part p equal to n. So this term p equal to n means this part 0, 1 minus theta whole power 0, 1. And p equal to n means n minus 1 factorial into n factorial. So Rn becomes what? If p equal to n, Rn is h to the power of n by n factorial f n a plus theta h is called, this remainder is called, this is important, you have to remember this, is called Lagrange's form of remainder. Is called Lagrange's form of remainder. Therefore, Taylor's theorem, you have to remember this now, Taylor's theorem with Lagrange's form of remainder. With Lagrange's form of remainder is f of a plus h equal to f of a plus h into f dash a h square by factorial to f double dash a and h to the power of n by n minus 1 factorial f n the derivative a plus, now remainder term is what? H to the power of n by n factorial f nth derivative at a plus theta h. This is Taylor's theorem with Lagrange's form of remainder. Okay, now one by one the observations, you have to remember this. Remarks. First one, in this one, put h equal to better. Remark 1. First one, put x equal to a plus h. Put x equal to a plus h. Why I am substituting? See, it will clear for you. X equal to a plus h means what is h equal to then? X minus a. H equal to x minus a. Now I will write only Lagrange's form of remainder, okay, which is important in solving problems. Then Taylor's theorem with Lagrange's form of remainder. Taylor's theorem with Lagrange's form of remainder is f of a plus h. A plus h is nothing but what? X. So f of x equal to f of a as it is. We are not eliminating a, we are eliminating h value, plus h into h means what? X minus a into f dash a. H square x minus a whole square by factorial 2 f double dash a, okay, and so on. And here I'm continuing, plus h x minus a whole power n minus 1 by n minus 1 factorial f n minus 1th derivative a. And what is the remainder term? Lagrange's form h power n by n factorial f n a plus theta h. Now let me write here a plus theta h. What is a plus theta? H value is what? A plus h value is what? X minus a. So theta into x minus a, right? So what is this becomes? Let me write h to the power of n, a value as it is, right? What is this becomes now? 1 minus theta into a plus theta x. Is it correct? A plus theta h value, a plus theta h value, a plus theta into h value x minus a, so theta x, and 1 minus theta into a, right? 1 minus theta into a plus theta x. 1 minus theta into a plus theta x. This is Taylor's theorem with Lagrange's form of remainder in terms of x. Why we are substituting this a plus h equal to x means to get f of x, to get f of x expansion. Now previously f of a plus h is there. Now if I put a plus h equal to x, I can expand f of x function in Taylor series, okay, sin x cos x for that. So how to remember? This is called once again Taylor's theorem with Lagrange's form of remainder about the point x equal to a, about the point x equal to a. So about the point x equal to a, you will get the terms x minus a in Taylor series. F of x equal to f of a plus x minus a f dash x minus a whole square by factorial 2 f double dash a, and so on. This is the first point. And in the next remark, Mclaren series. Second point, in this one, if I put a equal to 0, if I put a equal to 0, put a equal to 0, take this as expression 3 in 3, third expression. Then what is 3 becomes? Equation 3 becomes f of x equal to f of 0 plus x minus a, no, not a is not there. So x into a value 0, x into f dash 0 plus x square by factorial 2, a value 0 here, f double dash 0, and so on, x to the power of n minus 1 by n minus 1 factorial f n minus 1th derivative 0. And what is the remainder term becomes? X to the power of n by n factorial f nth derivative, this a value 0. So directly what is this? Theta x, equation 4. This is also important formula which is called Mclaren series, which is called Mclaren series with Lagrange's form of remainder. Mclaren series with Lagrange's form of remainder. Lagrange's form of remainder. Okay, this is also very important formula. This is nothing but Lagrange's always Maclaurin series means what? About the point 0. Okay, simply one can write this is Maclaurin series, Taylor series about the point x equal to 0. About the point, what is a equal to 0? So x equal to a equal to 0. Maclaurin series about the point x equal to 0, or Maclaurin's theorem actually. This is called series means you will get infinite number. One can say this is theorem. This is Maclaurin's theorem about the point x equal to 0. Okay, these two are the main cases. First one is Taylor's theorem with Lagrange's form of remainder. By substituting a plus h equal to x, you have to remember first one. And the second one, Maclaurin series, Maclaurin theorem. Now, third point is Taylor series. Previously, Taylor theorem, Taylor series. So, directly, Taylor series of f of x about the point x equal to a, about the point x equal to a is f of x equal to, series means it contains infinite number of terms, f of a plus, what is this? About the point x equal to a means you will get x minus a, f dash a, x minus a whole square by factorial 2, f double dash a plus x minus a whole cube by factorial 3, f triple dash a, and so on. There is no remainder term in series. This is Taylor series about the point x equal to a. Same logic. Fourth one, Maclaurin series. Maclaurin series. What is this Taylor series? Taylor series about what point? About x equal to 0 is called Maclaurin series. Is called Maclaurin series. Maclaurin series. And is about the point 0 means this is f of x equal to f of 0 plus x minus a value 0. So x into f dash a value 0, x minus a whole square, a value 0, f double dash 0, next x cube by factorial 3, f triple dash 0, and so on. This is Maclaurin series about the point x equal to 0. This is Taylor series about x equal to a. Okay, and this one Maclaurin theorem with Lagrange's form of remainder. And next one, this one Taylor's theorem with Lagrange's form of remainder. Okay, you have to remember these 4 formulae in solving the problems. Now, what are the failures of Taylor series? When Taylor series failures of Taylor series, or theorem, both are failures are same. First one, f of x or any its derivative becomes infinite. F of x or any of its derivatives becomes infinite. What is the meaning of this? Function is not continuous. F of x infinite means at that point function, I cannot put a definite point there. So f of x is discontinuous and the derivative is also discontinuous. Then Taylor's theorem fails. Exactly, see, in Taylor's theorem or Maclaurin series, what I required: first derivative, second derivative, third derivative, and a function value also. So either the function or any of its derivatives are infinite, then Taylor's theorem fails. Okay, second one. Discontinuity. F of x, left limit or right limit, the function may not be continuous. F of x or any derivative is discontinuity. Any derivative is discontinuous. Any derivative is discontinuous. Okay, these two are the main cases. Failures of Taylor's theorem. Same logic for Maclaurin series also. Maclaurin series means f of 0 or its derivatives at 0 may not exist. exist. And next one, you write. So I'll take these problems. See, any doubts in Taylor's theorem or Taylor's expansions? Check it. Yes. Not much problems are given here. Yes. Hello. Any doubts?
No, sir.
Okay. Now problems. Find the expansion of sin x with the Lagrange's form of remainder. Expansion of sin x with the Lagrange's form of remainder. Okay. Solution. First, take f of x as sin x. F of x as sin x. What is nth derivative? You know, in the intermediate. What is the nth derivative? Anybody? Nth derivative. Yeah. Hello. Sin x, cosine x. You have nth derivative formula directly. Sin of n pi by 2 plus x. This is for all x belongs to R. Agreed? Or you can find first derivative is what? Cosine x. Second derivative is what? Minus sin x. Third derivative is what? This is minus cosine x, and so on. See this formula? If I put n equal to 1 here, first derivative, n equal to 1, sin pi by 2 plus x cos x. If I put n equal to 2 gets cancelled, sin pi plus x, third quadrant. So minus sin x, pi is there. And if I put 3 pi by 2, minus cos x. Okay. So generalized nth derivative formula is this one. Then what is that? First write Taylor's theorem, and a point is not given. See, with the Lagrange's form of remainder, since the point is not given, take a equals to 0. If it is not given, means we have to expand a series about the point 0. Then Taylor's theorem or Taylor series with Lagrange's form of remainder. Lagrange's form of remainder is nothing but Mclaren series. Okay. Mclaren series with Lagrange's form of remainder is what? F of x equal to f of 0 plus x into f dash 0 plus x square by 2 factorial f double dash 0 and so on. What is the last one? Remainder term you have to write x to the power of n by fn theta x, right? This is with the Lagrange's form of remainder. So what is this one? F of x, this is sin x equal to f of 0, sin 0, 0, x into what is f dash? Cosine x. Cosine x, what is at point 0? Next, plus x square by factorial 2, f double dash, minus sin x at x equal to 0. Okay. Next one, plus x cube by factorial 3. What is this? Minus cos x at x equal to 0 and so on. And what is lastly? Plus x to the power of n by n factorial f nth derivative f theta x. What is in, if it is x, here x. Now theta x is there, therefore sin n pi by 2 plus theta x. N pi by 2 plus theta x. Okay. So this is, what is this? This implies sin x equal to x equals 0, 1. So x will be there. This is sine 0, 0. Next, minus x cube by 3 factorial. Similarly, another term will be 5 factorial and so on. And what is the last one? X to the power of n by n factorial sine n pi by 2 plus theta x. N pi by 2 plus theta x. This is the answer. Therefore, Taylor series or Maclaurin series. Mclaren series of sin x is no remainder term. So sin x equal to x minus x cube by factorial 3, x power 5 by factorial 5, and so on. And so on. And next one, you take this problem assignment. Find Maclaurin series of f of x equal to cosine x with Lagrange's form of remainder. With Lagrange's form of remainder. Okay. Now another problem. You take some. Not this. No, sine x, no need. This problem is easy. Tan x is easy. E power sin x. Okay, next problem. Expand e power sin x by Maclaurin series. By Maclaurin series up to term containing x power 4. Up to term containing x power 4. Solution. I will tell in two ways. First case is f of x equal to e power sin x. F of x equal to e power sin x. So what is the first Maclaurin series? Maclaurin series is f of x equal to f of 0 plus x into f dash 0 plus x square by factorial to f double dash 0 and so on. Take this as equation 1. Now one by one let us calculate. First one is f of x e power sin x. This is f of 0 e power sin 0. This is 1. Next f dash x. Next one, f dash x equal to e power sin x derivative e power sin x and sin x derivative cos x. So f dash 0. So if I put 0, this is 1 and cos 0 value 1. So this value also 1. Next one, f double dash x, UV method. Otherwise, one simple way. Yeah, I will write like this. This can be written as what? Okay, let me write one more step. That is f dash x equal to what is e power sin x? Nothing but f of x. So I will write f of x into cosine x. Okay, this implies one more derivative, f double dash x equal to UV method f dash x into cosine x plus minus f of x as it is cosine x derivative negative sin x. So from this, f double dash 0 is nothing but f dash 0 into 1 minus sin 0 0 0. What is f dash 0? Already I had f dash 0 value 1. So this is 1 into 1. This is also 1 value, right? And next one, f triple dash x. F triple dash x. I cannot write anything, right? Okay. For this, one more derivative, right? For f dash, f double dash, cosine x as it is, minus f dash constant, cosine x derivative minus sin x. So minus taken. Next, minus coming to this one. F derivative f dash x sin x minus f of x into this is cos x. F of x into cos x. Now let me simplify this. Coming to double derivative, what are the terms? F dash cos x, it is there. F of x sin x, it is not there. It is not there. So let me write as well. F double dash x cos x, f dash x sin x, it is not there. Only f of x cos x value I know, f dash. So let me write, these two are same. 2 into f dash x sin x minus this is f dash x. This is f triple derivative. Since required series is up to x power 4, I have to calculate up to fourth derivative if it is not 0. So f triple dash 0 value is what? F double dash 0 into 1 minus 2 f dash 0 into 0 f dash 0. So f double dash 0, this value is what? 1. F dash 0 value 1. And anyway, this is 0. This is 1. Oh, 1 minus 1, 0. Right? Next, coming to fourth derivative. F fourth derivative for this. F triple derivative cosine x minus double derivative minus sin x minus 2f double derivative sin x minus 2f dash x cos x minus f double derivative x. So f fourth derivative 0. F triple 0 is 0. So first term 0 and sin 0 0, sin 0 0, and 2 into f dash 0 1 cos 0 1. F double dash 0 is value 1. So this is minus 2 minus 1 minus 3. That's enough. Okay. Therefore, for up to fourth, so f of x equal to f of 0, equation 1. In this one, f of 0 value 1. So f of 0 plus x into f dash 0 1 plus x square by factorial to f double dash 0 1. Which one is 0? Only triple derivative is 0. X cube by 3 factorial triple derivative 0. X power 4 by 4 factorial fourth derivative minus 3. Fourth derivative minus 3. Therefore, f of x equal to what? 1. Okay, what is this? F of x is what? E power sin x. E power sin x equal to 1 plus x square by 2, and this value 0 minus x power 4 by this is 24. 24 means 8 and so on. This is one way of doing. Okay. And next one, R. Another way is R. We know that what is e power x expansion? Anybody? We know that Mclaren series of e power. Mclaren series of e power x is. What is e power x expansion? 1 plus x square by factorial 2, x cube by factorial 3, and so on. And since x power 4 is required, by factorial 4 and so on. Right? But what is my function given as? Therefore, e power sin x expansion becomes what? In place of x, you write sin x. Sin x whole square by factorial 2. Sin x whole cube by factorial 3. Sin x whole power 4 by factorial 4 and so on. Now, you know sin x expansion. We have sin x expansion. What is this? X minus x cube by factorial 3, x power 5 by factorial 5, and so on. So substitute here. Therefore, e power sin x becomes what? E power sin x 1 plus, and I need up to what? X power 4. So no need of this x power 5 term. So I will write x cube and dash plus x minus x cube by 3 factorial dash whole square by 2 factorial. Right? And next, x minus x cube by 3 factorial and so on whole cube by 3 factorial. Okay, plus last one, x minus x cube by 3 factorial and whole power 4 by 4 factorial and so on. Okay, see this technique without calculating any derivative, this expansion, second case. So 1 plus x must be there, minus x cube by 3 factorial must be there, since required series is up to x power 4. So these terms are considerable. Plus now in the second term 1 by 2 factorial, in this x minus x cube whole square, how many terms are required? Required is up to x power 4 only. So a first a plus b plus c plus d whole square. What are the first terms? A square plus b square plus c square plus d square. Using that, first term is what? X square will be there. Second term x power 6, but not required here. But not required here. So 2ab term will be required. So I will write plus 2 into a into b, x cube by 3 factorial. 2ab term, this is x into x cube, x power 4 is required. All other terms are neglected. All other terms are neglected. I think it is clear. Coming to second one also, third term, plus 1 by 6, 3 factorial. A plus b plus c plus d whole cube means what? First terms are always cubes. So x cube is required. X cube. Done. First one is x cube. Next b cube is not required. Next, what is the term? 3ab square, not required. Right? 3ab square also not required. And 3ab square, 3a square b is also not required. All other terms are of degree more than 4. Of degree more than 4. So neglected. And in the last one, 1 by 24, only x power 4 is required. First term, x power 4 is required. All other are neglected. Since series is truncated up to x power 4. So now let me club the similar terms. X minus x cube by 6, this one. This is plus x square by 2. And what is this? 2 gets cancelled. Minus x power 4 by 6 you will get here. And coming to here, plus x cube by 6. And coming to here, x power 4 by 24 and so on. Okay. So what is this becomes? 1 plus similar terms, x as it is. Only x square is only one term. Next, x cube terms. Plus x cube minus x cube gets cancelled. X power 4 terms. This is what? Minus 1 by 6, 1 by 24. So 6 fours are minus 4 plus 1, minus 3 by 24. Minus 3 by 24 means minus 1 by 8. So this is minus x power 4 by 8 and so on. This is expansion of e power sin x. Both are same. Yeah, where is it? Yes, 1 plus x square by 2, x power 4 by 8. 1 plus x power 4. What is the benefit of second case? Without calculating any derivatives, just we are using the expansions in the given function. That's it. Okay, this is one model. And next one, log 1 plus x square. You take this one assignment. Expand log 1 plus sine square x. Log 1 plus sine square x in powers of x. In powers of x up to x power 6. In powers of x up to x power 6. Try this. Choice is yours. You find the derivatives. Another case is what? Write the expansion for sin x. Then make it whole square. Take it whole square. Then simplify it. And use log 1 plus x expansion. Okay. Log 1 plus x expansion. In place of x, replace x by sin square x. Series expansion. That's better. Otherwise, you calculate the derivatives. Answer is x square minus 5 by 6 x power 4 plus 32 by 45 x power 6 and so on. Right. Now, do you know Leibniz rule for successive differentiation? Leibniz rule for successive differentiation? Anyone answer?
No, sir.
No,
Successive differentiation.
no, sir.
ఐఐటి పిల్లలు మీరు అందరూ సక్సెసివ్ డిఫరెన్షియేషన్ లేదా? ఓహో, సక్సెసివ్ డిఫరెన్షియేషన్ లేదా మీకు? Okay, so I have to introduce successive differentiation. Sure, successive differentiation leda?
No, sir, it's not.
Not there,
Oh,
sir.
మా అప్పుడే లాంగ్ బ్యాక్ నేను చదువుకున్నప్పుడే సక్సెసివ్ డిఫరెన్షియేషన్ ఉంది.
We don't know, sir.
సరే సరే ఓకే, టేక్ సమ్ ప్రాబ్లమ్స్. అసైన్మెంట్ 1, expand all these problems, expand. Let me tell you one problem in terms of ones. Yeah, just 5 minutes I will take. Okay, later on I will give assignment. Expand log x to the base e in powers of x minus 1, in powers of x minus 1, and hence evaluate log 1.1, and hence evaluate log 1.1 to the base e correct to 4 decimal places. Correct to 4 decimal places. Solution: f of x is taken as log x to the base e, and what is the series is required in terms of what? X minus 1, that is Taylor series, not about the point x equal to 0. Okay, about the point x equal to 1 here, Taylor series about the point x equal to 1 is x equal to a formula. Remember that. What is that? F of x equal to, sure, let me write first x equal to a, f of a plus x minus a into f dash a, x minus a whole square by factorial to f double dash a, and so on. Equation 1. Here a value 1. Okay, here a value 1. Therefore f of x equal to, don't take this as 1, f of x equal to f of 1 plus x minus 1 into f dash 1, x minus 1 whole square by factorial to f double dash 1, and so on. This is equation 1. So let me calculate one by one. F of x equal to log x to the base e. So f of 1 log 1 to the base e 0, f dash x 1 over x, right? F dash 1, this is 1. Next, f double dash x minus 1 over x square, f double prime 1 negative 1, f triple prime x 2 over x cube. So f triple prime 1 is 2. And finally, let me calculate one more, fourth derivative. This is minus 6 upon x power 4. This is fourth derivative at 1 is minus 6, and so on. So substitute in equation 1. Therefore 1 implies f of x is nothing but log x to the base e. F of 1 first term, that is 0. F of 1 0, x minus 1 into f dash, that is 1, f dash 1 1. Next one, plus x minus 1 whole square by factorial to f double dash value negative 1. Next, plus x minus 1 whole cube by factorial 3, f triple dash 2. Next, x minus 1 whole power 4 by factorial 4, this is negative 6, and so on. Simplify this. This log x equal to, this is x minus 1 minus x minus 1 whole square by factorial 2 plus x minus 1 whole cube by 3. Okay, you can write this one 2 directly. Next, minus x minus 1 whole power 4 by, this is 24, 4, and so on, is the expansion of log x in powers of x minus 1. in powers of x minus 1. Okay, and what is the last question? Log 1.1. So put x equal to 1.1. Log 1.1 to the base e equal to 1.1 minus 1 minus 1.1 minus 1 whole square by 2, 1.1 minus 1 whole cube by 3, 1.1 minus 1 whole power 4 by 4, and so on. And so on. Simplify, and you will get the answer. What is this? 0.0953. Correct to 4 decimal places. 09, after decimal there must be 4 decimal values. 0953. Okay, this is one model problem. This is expansion about a point. Expansion about a point. Similarly, you take this. Expand f of x equal to sin x in powers of x minus pi by 4. In powers of x minus pi by 4. Or expand, question may be f of x equal to sin x about the point x equal to pi by 4. X equal to pi by 4. Okay, just today we have discussed only simple problems. Successive differentiation formula must be, I will tell tomorrow, this one, successive differentiation. Any doubts?